So first of all, the OSI and TCP IP models, application, presentation, session, transport, network, data link, and physical. This is the hierarchical structure of the Open Systems Interconnect model, or the Open Systems Interconnection model. And you want a mnemonic to memorize it. So the first time I taught this class 17 years ago, one of the students said their mnemonic was, "Please do not throw sausage pizza away." And 17 years later, I haven't forgot it. So that's what one of the students came up with. Please do not throw sausage pizza away. So please do not throw sausage pizza away. Physical, data link, network, transport, session, presentation, application. Now, do you have to have this memorized for the CCNA? Absolutely. You need to know what the 7 layers are. Now, the OSI model was a theoretical model. It's never actually implemented. It's just conceptual. What we actually have is the internet, and the internet is the TCP/IP protocol suite, or the TCP/IP internet suite of protocols. It's a whole suite of protocols. It's not just TCP and IP, it's a whole giant suite. And we have only 4 layers. There's the application layer, the transport layer, the internet layer, and the network access layer. And we don't talk about numbers. If we're talking about numbers, everybody thinks OSI. So TCP/IP, application, transport, internet, and this network access layer, this is oftentimes called the link layer, the link layer. So Cisco calls it the network access layer, but it's oftentimes referred to as the link layer. Layer 3, the network layer in the OSI model, is the internet layer in the TCP/IP model. I'm always good with that. Why? Because this is the layer of IP, internet, IP, this is that layer. Transport's transport, that's the super easiest. Okay, and then the session, presentation, and application layer are all bundled into one at the application layer. It does make sense. It makes sense, and I'll show you why. The reason is, at the application layer, whether it's application, presentation, or session, we're just dealing with data here. Your data has not been broken up into bits yet, into pieces yet. Hasn't been broken up into packets. The data gets broken up at layer 4. It gets turned into segments. This is where it gets broken up into pieces. At layer 4, the data is called segments. At layer 3, we call the data packets. And layer 2, frames. And at layer 1, bits. Also, sometimes at layer 3, they call, instead of packets, they use the word datagrams. Why? Because sometimes we use the term packets like with a big P, like it's all broken up into packets. So when they say that, you wonder, hey, are they meaning packets like generically, or are they meaning packets on the 3rd layer? Right? So oftentimes you have to kind of figure that out. Like sometimes in the reading, when they say packets, they mean the 3rd layer PDU, protocol data unit, the unit of data that exists at this layer. Okay. Devices. These layers also coordinate to devices. So at layer 1, this is the layer of hubs, network interface cards, wireless access points, but more importantly, layer 1 is the layer of the media, of the wire. It's the layer of the wireless signals, the fiber optic wire, the Ethernet copper cable. It's the layer of the wire. However, there are devices that function on this layer. A wireless access point, a NIC, a hub, all function at layer 1, but a lot of those devices also function at layer 2. So notice wireless access point, NIC. At layer 2, a device that's specific to layer 2 would be a switch. A bridge is another fancy term for a switch. Well, a switch in the early days was called a bridge. Why? Because it didn't have a lot of ports. It was just 2 ports. In one, out the other, like a bridge over one end, out the other. But it's multi-port, a switch. They oftentimes, when they first invented switches, they called them multi-port bridges. Then you've got layer 3, a router, a multi-layer switch, which is a switch and a router combined, a wireless router, that's layer 3 device. And then at layers 4, 5, 6, and 7, layer 4 firewall, layer 7 firewall is a fancy firewall that can actually inspect packets at the application layer. It can actually look at the programs as the packets go across the network. So notice how NIC here and here, wireless access point here and here. So that kind of makes sense, like the network access layer sometimes involves both of them. The NIC exists at this whole link layer. The protocols. So these are the protocols of the Internet Protocol Suite. At layer 1, And layer 2, let's say, because we're talking about the Internet Protocol Suite, so really, right, we're talking about the network access layer here. Media access control, also MAC addresses. ARP, address resolution protocol. This is the layers of Ethernet. And then there's other things here that you'll need to know about. PPP is a WAN protocol. DSL is a WAN protocol. This is a tunneling protocol. This is wireless Ethernet. This is wired Ethernet. Ethernet is the 802.3 specification. Wireless Ethernet, Wi-Fi, is the 802.11 specification. Do you guys see this? SONET and SDH? This is fiber optic high-speed WAN stuff. That's hybrid. That's fiber optic backbone. 100 gigs per second, that type of stuff. We're going to learn about CDP and LLDP in this course. HDLC, this is a serial connection. PPP is a serial connection. WAN connection. WAN connection. You guys have to learn ARP, address resolution protocol, massively. Okay. IPv4 and IPv6 we're going to cover. ICMP, this is ping amongst other types of messages. Right? Internet Control Message Protocol, and this is for IPv6. IPsec, this is IP security built into the lower layers. This IPsec provides security to packets on the internet at layers 3, 2, and 1. How awesome is that? This is routing protocol stuff. These are routing protocols. You're going to learn them. Then you got TCP and UDP. This is the transport layer right here. This is what my lecture is going to be about that I'm going to record later tonight on TCP. It's going to be cool. Then at layers 5, 6, and 7, we've got these protocols here. These are protocols that the user uses. The user uses a web browser. It's using HTTP. The user puts a domain name into the web browser. It uses DNS client. The user gets an IP address automatically. He's using DHCP client. FTP with the FTP client. Telnet with a Telnet client. Right? There's servers for all of these too. Right? You have clients and then you have servers. SSH, you SSH in, remote connection, mail, SMTP, POP is your mailbox, IMAP is a mailbox, a network time protocol. This is simple network management protocols used for managing the network. This is transport layer security, which used to be called secure socket layer. The new term for this is TLS. Then we've got BGP. And this is Border Gateway Protocol. This is the routing protocol of the internet in between internet service providers. RIP is old school routing protocol. And then SIP, this is used for voice over IP. All right, moving on. At the application layer, what is the function? Basically, you need to know what each layer does, because you're going to get a question multiple choice, let's say, on the CCNA. You have to say, well, they'll say, if the layer does this, which one is it? Is it this one, or this one? All right, well, application layer. Applications, protocols, and services that interface with the end user. So what do we know? These are applications that the end user uses, like a web browser is using HTTP. What about the presentation layer? Well, the data is formatted. It's converted from different formats, or converted to different formats, and it's encrypted, decrypted, compressed, decompressed, and sent or presented to the user. And like when I think of the presentation user, when I think of the presentation layer, I think of MIME types, right? Like MIME types to show different data types in emails and stuff like that. Then the session layer, open, close, and manage a session between end user application processes. So in other words, this is stuff that's built in where the application itself can, basically manage that connection or that conversation between end users. Open, close, and manage a session between end user application processes. So it's built into this upper layers. And once again, we're talking the application layer in the TCP/IP model, but this is application here, presentation here, session here. Okay, moving on. Transport layer, super important. Facilitates end-to-end communications between multiple applications simultaneously. So this is always confusing, because when I see end-to-end communications to the end user, I think sometimes they'll say facilitates end-to-end communications for the end user. I think, oh, application layer. No. The transport layer services the upper layer because it provides ports, and each port stands for a different application. So like port 80 is HTTP, the web, right? Port 22 is SSH. Port 21 is FTP. So by putting these ports here at the transport layer, it facilitates the programs that want to communicate on different ports, and it allows for multiplexing or multiple services to be sent over the wire simultaneously. Okay. At the transport layer, we can have reliable service or unreliable end-to-end data transport and data stream services with TCP, UDP, or a newer version is SCTP. That's newer. But mostly we're talking about, in this course, TCP and UDP. TCP is reliable, UDP is unreliable. So like all of those upper layer protocols, like HTTP uses TCP because it needs to be reliable. However, DHCP does not need to be reliable because it just, it's giving out IP addresses and the client's going to keep asking until it gets an IP address. So UDP DHCP uses UDP, right? DHCP uses UDP. It doesn't need that same reliability like SMTP mail or HTTP web. All right. Connection-oriented, connectionless communications and data stream services, session establishment and termination. So this is another things that are provided. If you're using TCP, it's connection-oriented with a three-way handshake. If you're using UDP, it's connectionless. And data stream services, session establishment and termination. So in other words, we start the conversation and end it if it's TCP, that type of thing. The network layer. What do we do at the network layer? Also known as this is the name of the network layer. It's also known as the internet layer on the TCP/IP model, provides host addressing IP. This is also called logical addressing. Chooses the best path to the destination in the network, routing, choose the best path to the destination network, routing. Switch packets out of the correct interface, forwarding. Maintain quality of service, QoS. At the network layer or the internet layer, we can set up quality of service. So like if you have voice over IP, you need more bandwidth, more quality, guaranteed bandwidth. If you have video, you need more bandwidth. But if you have an email, well, it can wait a little bit. Who cares, right? But that doesn't work if you have a phone call, right? Then you need more bandwidth. So that's what QoS does. It prioritizes traffic. And those flags are those switches that let you know, hey, these packets need more priority. They're built into this layer. All right. Connectionless end-to-end networking. In other words, we're providing end-to-end networking. In other words, IP addresses can be networked across the world, across the internet, and there does not have to be a prior connection. It's existing without that. Why? Because the connection part, the three-way handshake and establishing the connection, that's handled at the transport layer. So IP is known as a best effort connectionless end-to-end networking protocol. All right, the data link layer. The data link layer is pretty interesting. The data link layer is the layer of your Ethernet NIC, right? The data link layer is the layer of Ethernet. It's the layer of your NIC. It's the layer of where you have Ethernet cables. And it comes with two sublayers. The LLC, the logical link control, the LLC, which is 802.2, that's the upper sublayer, provides services to the upper layers. So the LLC talks to the network layer. The LLC is right here. It's the upper part of the data link layer. It talks to the network layer, provides services to the upper layer. And then the media access control defines how devices access the medium. We're talking here media access control. We're talking about carrier sense multiple access with collision detection for Ethernet that's wired, and carrier sense multiple access collision avoidance if it's Wi-Fi. All right. Media access control, if it was a token ring network, could involve token passing, but we don't use token ring networks anymore. We use Ethernet networks, right? Ethernet won that war a long time ago. So when we use Ethernet, hosts, computers, and devices have host addressing at layer 2. At the data link layer, they have MAC addresses. So if you want to actually deliver data from my computer to your computer, it's going from my MAC address to your MAC address. It's getting delivered to a MAC address. So not only do you need IP addresses to navigate over the internet, right? But when you get to that local area network, when you get to that end network, you need MAC addresses to deliver it, right, on the local area network, on the Ethernet network, right? Now, layer 2 is not always a local area network. At layer 2, we have layer 2 also with wide area networks. So if we're on a local area network, we're using an Ethernet frame. However, if we're on a wide area network, there's a different type of frame for a layer 2 frame in a wide area network. So it looks different. So for example, an Ethernet frame in a local area network, or a PPP frame, a serial connection on a wide area network. Maybe not a PPP frame. It could be a HDLC frame, or it could be a different type of frame, but not necessarily an Ethernet frame if it's a wide area network. Also, the data link layer provides error checking. In other words, if there's a corrupted frame, why am I using the word frame? Because that's the PDU at the data link layer, packets at the network layer, frames at the data link layer. So error checking, right? So if they're bad frames and there's missing data, the data is corrupted, the data link layer will drop the frame, or it'll see that, it can error check and say, hey, this frame's bad. All right. I skipped talking about the physical layer because that's the layer of encoding ones and zeros on the wire with electricity or with light pulses, if it's fiber optic, or radio waves if it's wireless. So I'm not talking about layer 1, the physical layer, but fine. All right, another topic in this week is encapsulation and decapsulation. In other words, when we're encapsulating, we're making packets, okay? When we're decapsulating, we're taking those packets and putting them back together so we can get the data. So decapsulation, we want to return the packets back to data. Encapsulation, we're making packets. So when we encapsulate, we move down the model. In other words, you're using your web browser, you're using an application like a web browser, HTTP, and then boom, it goes down here. When it hits the transport layer, it gets broken up into pieces, and the transport layer header is added on, and then the network layer header, and then the data link layer, the Ethernet frame header, and then the physical layer, it's turned into ones and zeros, and then it goes over the wire as ones and zeros, electrical pulses of electricity on the wire. When it goes back and reaches its destination, it goes back up the model and gets turned back into data and gets, viewed by the user that requested it, or it gets to the endpoint. So that's how it works. So data at the application layer, notice at the transport layer, it gets broken up into pieces. Each piece has a transport layer header and then the data. Header, data, header, data, header, data. So these are the pieces. These pieces are called segments. Then one of these pieces, right, here it is, there's the piece, the transport layer header and the data, and then at the packet adds the network header on there. So now we've got source and destination port numbers. Now in the network header, we have source and destination IP addresses. Now at this layer, we add on the frame header. So now we've got the data, right? Let's say this is the raw data here that we have. This is the picture or the email or whatever. We have the transport header with the source and destination port numbers, the network header with the source and destination IP addresses, and then the frame header with the source and destination MAC addresses. There's also more information in those headers. Those are just the most important components, the addressing. Also, in the Ethernet frame, there is a trailer added, and the trailer will have a hash in there used for making sure that there's no corruption, error checking, right? And then at this layer, at the physical layer, it gets turned into bits. So, and this represents one packet here, let's say. One packet of ones and zeros. And, right, or, one, at this point, when it gets to here, we'd probably say this is one frame. But anyway, the data turns into segments. Each segment gets added with the packet. The packet gets turned in with a frame, and then the frame into the bits, and the headers are added on. This is what enables it to go across the internet and reach the destination, because we need the addressing, right? Does your letter reach a destination without a name and address? Zip code? No, it does not.